Alright, in this last video for lesson 2.9, we're going to be looking at how to solve equations involving radicals. Now this can be really tricky. You want to make sure that if your algebra skills are low, that you pay attention, follow along, pause this video probably frequently, soak it in, make sure that you understand each step that I do. Because first thing we want to do is when there's just one radical, we're going to isolate it on one side and then square both sides. So this is going to get, like I said, algebra intensive. And so for the first one, I want to get the square root all by itself. I want to get the radical all by itself. So I'm going to subtract 5 from both sides. We would have 2 times the square root of x. 23 minus 5 would be 18. So we would have 2 square root of x equaling 18. Divide both sides by 2, and I get the square root of x equals 9. Now this one's relatively simple because all I got to do now is square both sides. And when we square both sides, we get x equals 9 squared, x equals 81. And you should always check your answers just like before, because sometimes you could end up with extraneous solutions. And so if I put 81 in here for x, sure enough, square root of 81 is 9. 2 times 9 is 18. 5 plus 18 is 23. So that checks off. So perfect. That is our solution. Easy enough. Well, let's look at this next one. This next one is where it's going to kick it up a notch. So again, we need to isolate the radical. We want to get this by itself. And so I noticed that on the, and by the way, do not just take 16 minus 5. I just noticed that you don't want to do that because that minus 5 is being multiplied times the radical. So we're going to have to divide that later. So I'm going to start by subtracting 16. Well, actually, scratch all that. Let's do this. This will be even easier. I'm going to add 5 square root of x plus 40 to both sides. There we go. This will be not real easy, but a little bit easier. So when we do that, on the left we'll have x plus 16. On the right, I'm going to have 5 times the square root of x plus 40. So again, we want to isolate the radicals, so I'm going to divide both sides by 5. So I'd have x plus 16 divided by 5 on the left, and on the right now that 5 would be gone. Okay, you ready for this? I hope so. Well, we're going to square both sides. So when I square this fraction, that means I'm going to square both the numerator. I'm going to multiply this by itself. Okay, that's what it means to square something. We multiply it times itself. So with that x plus 16, I'm going to do that over here. I'm going to take x plus 16 times x plus 16. So when I do that, we would have x squared. This would be 16x. This will be 16x. And 16 times 16 is 256. So what we have in the numerator would be x squared plus 32x plus 256, all divided by 25, because we would multiply 5 times 5 as well and get 25. Then on the right side, we would have x plus 40. So guess what? We have a fraction here. Okay, so this is involving a lot of stuff that we've been doing already in this single section. So the next thing I'm going to do is I'm going to multiply by that denominator. So I'm going to clear out the fraction. So I'm going to multiply everything by 25. So on the left side, that's going to stay x squared plus 32x plus 256. Because remember, 25 goes into 25 one time, so there's nothing to multiply the numerator by. But on the right side, we're going to distribute, multiply 25 times both the x and the 40. So now I'm going to solve this by getting everything all on one side. So I'm going to subtract 25x from both sides. So when I do that, I would get 7x. And then when I subtract 1,000 from both sides, I get minus 744 equals 0. So at this point, we have a quadratic that we're solving. So if you want, you can solve this by using the quadratic formula. Otherwise, I don't even have to break this up into four terms, okay, because my coefficient here is just a 1. So all I need to do is, if I could just find two numbers, I could make this a lot easier for myself. If I could find two numbers that multiply together to be negative 74, that add together to be a positive 7, I'll have my answers. Well, again, that takes a little bit of digging around. Okay, so I'm going to admit, when I did this on my own, I had to take 744 divided by, I started with 2, but I knew it wasn't going to be 2, so I just started with 2. But you might want to start with a bigger number and just try numbers like 8. try 12, try 14, try 15, try 16, try 17, and keep going with numbers until you find a larger number that works. And you end up getting to 24 and 31 multiplied together to be 744. So if you take 744 divided by 24, you get 31. And if you make this a minus and this a plus, negative 24 times 31 it would be negative 744. Negative 24 plus 31 would be a positive 7, and equaling 0. So then I'm just going to set each of those factors equal to 0 and solve, and I would get x equaling 24, and I would get x equaling negative 31. Now I want to check to see, are both of these solutions? Well, if I try 24, again, I'm going to go back up to the original equation. Okay, I'm kind of running out of space here, so I'm just going to talk through this. If I put 24 in there for x, let's put it in the square root first. 24 plus 40 would be 64. And the square root of 64 would be 8. Okay, so we would have 5 times 8, or 40 there. So we'd have negative 40. And if I put 24 out in front here, 24 plus 16 would be a positive 40. So we'd have 40 minus 40. Sure enough, that's 0. So that one works out. Let's try negative 31. If I put negative 31 in here, negative 31 plus 40 is 9, and the square root of 9 is 3. So we'd have 5 times 3 is 15. If I put negative 31, though, out here, negative 31 plus 16 would be a negative 15. And negative 15 minus 15, because this would be minus 5 times 3, negative 15 minus 15 would not be 0. Negative 15 minus 15 would be negative 30. So the second one does not work. So that is not a solution. So x equals 24 would be our only solution. So again, just like when we're working with absolute value problems, with these you also have to check your solutions. All right, I know we've only looked at just those two problems, and that second one was the one that was trickier. But I want you guys to try this one on your own. This one's a little bit easier in the sense of the absolute, or the square root rather, is already by itself. So you're going to start this one out by getting rid of the radical by squaring both sides. So I'll give you that hint. And x plus 5 is not x squared plus 25. You have to actually multiply x plus 5 times x plus 5. So go ahead and work that out and see if you can get the correct answer. And so pause the video and hit play when you're ready to check to see how you did. All right, let's see how you did here. So again, on the left side, you'd get 15x plus 19. I'm not going to show my work for this, but if you'd multiply x plus 5 times x plus 5 using that box method, you'd end up with x squared plus 10x plus 25. Okay, hopefully you got that part at least. So now we're going to group everything together on one side. So since my x squared is already on the right, I'm going to subtract 15x and 19 from both sides. So when I do that, when I subtract 15x from 10x, I'd end up with minus 5x. And when I subtract 25 minus 19, I'd get 6. So we get x squared minus 5x plus 6. So this is one of those where it is a little bit easier. So we're trying to find two numbers that multiply together to be a positive 6, that add together to be a negative 5. Well, hopefully you got negative 2 and negative 3. Negative 2 times negative 3 is 6. Negative 2 plus negative 3 is negative 5. If I set each of those equal to 0, I would get x equals 2. And I would get x equals 3. But we want to check to see that both of those solutions work. So let's try 2. If I put 2 in there, 15 times 2 is 30. 30 plus 19 is 49. And the square root of 49, so we'd have the square root of 49, which is 7. And then the right side, we would have 2 plus 5, which is also 7. So that one checks out. If I do 3, 3 times 15 is 45. 45 plus 19 would be 64, which we know is going to be 8. And then on the right side, if I put 3 plus 5, if I put 3 in for x, I would get 3 plus 5, which is also 8. So both of those end up checking. So that is both solutions here for this guided practice problem. All right. One more problem. I'm just going to say it. This one's going to be a doozy. Okay, this one is going to take and be a tricky problem. We want to make sure you need to know how to do this type of problem when you have two square roots, two radicals involved. You'll see a problem like this in your assignment. So the first thing, we're going to isolate one of the radicals and square both sides. Okay, so we're going to get one of the radicals by itself. And then we're going to square both sides. Then after we do that, we're still going to end up with a radical, and you'll see why here in a little bit. So write down these 3 steps, these 3 bullet points. So isolate the remaining radical and square both sides again. And then what's left over, it'll be a quadratic, so you can solve that quadratic by factoring, completing the square, or using the quadratic formula. So again, this is not going to be easy. So what I'm going to do, though, is I'm going to add square root of 9 minus x to both sides. Okay, so we're going to get this one by itself. So if I add that to both sides, I would have on the right side, I'll have 9 minus x under the radical, minus 2. On the right side, I have negative 10 minus 2x. Okay, so this is where we're going to square both sides. Now when I square the right side, that's just going to get rid of the radical. But on the left side, I have this that I have to do. And I'm making this a large box for a reason, so do the same. Square root of 9 minus x, that's a single term. So we still have 2 terms times 2 terms here. And then we're going to multiply that times square root of 9 minus x minus 2. Now when I take square root of 9 minus x times square root of 9 minus x, the roots cancel each other out. Okay, so we're left with just 9 minus x. When I take square root of 9 minus x times negative 2, I'm going to put that negative 2 out in front, and then we'll have 9 minus x under the radical. Same thing with this one. And negative 2 times negative 2 would be a positive 4. So when I combine like terms, we would have 9 plus 4 is 13. Okay. I'm adding these two together. So 9 plus 4 would be 13. And then we're going to have minus x. Then I'm going to combine these like terms. Now the square root of 9 minus x is kind of like a variable. So we would just combine the 2 terms outside, the negative 2 and the negative 2 that are outside of there. Like if I had negative 2a minus 2a, it'd be minus 4a. So this will just be minus 4 times the square root of 9 minus x. Equals on the right side, so again, by squaring it, I remove the radical, so we'd have negative 10 minus 2x on the right. Oh, okay. You with me so far? I hope so. So I just want to take a minute and go back up to those bullet points. So we did this first one. We isolated one of the radicals and we squared both sides. So remember I said that there's going to be remaining radicals. So we need to isolate that remaining radical and square both sides again. So I could, so what I'm going to do is I'm going to add 2x to both sides. So negative 2x plus 2x would just be x. I'm going to add this 10 to both sides. And 13 plus 10 would be 23. Now if you're wondering why I'm doing it this way, it's so I can have a positive variable there. So it gets a little bit less tricky if I'm working with positive variables. So I added 2x, so then that way I would have negative x plus 2x, which is a positive 1x. Added 10 to both sides, so I have 13 plus 10, which is 23. But now what I want to do is I want to get rid of this, so I'm going to add that to both sides. So I'm going to add 4 square root of 9 minus x to both sides. So I'm just going to write it like this. So on the right side, I ended up with 4 square root of 9 minus x. Now remember, we're trying to isolate the remaining radicals. So I want to get that radical by itself, so I'm going to divide both sides by 4. If you want to do that in 2 steps, you can. So that way you can look back in your work and see how we got this. But for space sake, I'm just going to write it like this. X plus 23 divided by 4 equals the square root of 9 minus x. Now I've obviously ran out of space here, so I'm going to go to this next slide. I'm going to rewrite where I'm at right now. So we are currently at x plus 23 divided by 4, and on the right we have the square root of 9 minus x. So remember what we're going to do now, just like we did before, we're going to square both sides. Now when I square both sides, on the right side we're going to be left with just 9 minus x, but on the left I have to take x plus 23 times x plus 23. So when I do that, we get x squared. This will be 23x. This will be 23x. Now 23 times 23 is going to be a big number. That's going to be 529. All right, so my numerator, when we square that numerator, we end up with x squared. Combine the 23x's. 23x plus 23x would be 46x plus 529. In our denominator, when I square that, 4 times 4 would be 16. And on the right side, we'd have 9 minus x. With me so far? Well, now we're going to multiply everything by 16. And when we do that, 9 times 16 is 144 minus 16x. All right, so now what we want to do is we want to combine like terms. So I'm going to add 16x to both sides. So we would have x squared. So 46 plus 16 would be 62. So that'll be 62x. Subtract 144 from both sides. So 529 minus 144 would be 385. And we got that equal to 0. All right, so again, we're going to break this down. We're going to factor this down. Now what I'm going to do is I'm going to try to figure out what two numbers multiply together to be 385 that add together to be 62. I don't know what those are. I have to guess and check. It is not just a simple, ooh, I just pulled this out of my head. I'll be honest. I tried 385 since it ends in 5. I tried 5. 385 divided by 5 gave me an integer, but they didn't add up to be 62. So I took 385 divided by 6. That gave me a decimal. 385 divided by 7. Well, that one actually worked because 385 divided by 7 was 55. And then I recognized that, well, 7 plus 55 is 62. So this breaks down to be x plus 7 times x plus 55. So we get our two solutions, x equaling negative 7 and x equaling negative 55. But we got to check to see if these both work. For time's sake, I'm just going to tell you, when you put negative 7 in there, it works. But when we put negative 55 in, again, you can do this in your calculator. You can do it in your head. It's a little trickier, in your head. But you'd find that x equals negative 55 does not work. So our only solution for this one is x equaling negative 7. So again, it's really important to always check your answers because you want to be looking for extraneous solutions, which would be solutions that even though we didn't make any mistakes in our problem, they don't work in the original equation. So a lot of algebra there. I'm going to be completely honest. This last one, there's a lot of work there. Okay, and your sheet on your homework or in your notes probably took a half a page of notes just to do one problem. So it's all we're doing is we're taking a lot of concepts that we already know how to do and putting them together into a single problem. So you need to have patience with these. You're going to struggle at first. Okay, let's just face that. Let's call it what we see it. We're going to struggle, but you need to work through it. Okay, you need to work through these problems in your assignment. I'm willing to support you, so please make sure to reach out if you have any questions, because I want to make sure that you can get over this hurdle and you can know how to do these types of problems. So good luck.